Hey guys, welcome to class. My name is Clinton P. I'm your math instructor for the rest of your time in the 10th, 11th, or 12th grade for this year. Now, this math class or these math classes we are going to have, they are going to be very intensive. So I want you to put yourself into the attitude of learning the subject. Math is not something difficult, but most people perceive it to be difficult. And as you and I both know, life is also difficult. So let's get over the idea that certain thing is difficult and that we cannot pursue it. I decided to record a video for each of the topics we'll be doing for each period because I want to help students to quickly learn the material. So what we are going to be doing, we are going to be sacrificing our time and our energy to record videos for you guys so that you can use those videos to go over the lesson even if you did not understand what we said in the class. That's what I want to do, and I hope we'll get the energy and the ability to do them. Secondly, I want to give you the courage that anyone can learn math because it is very possible for you to learn math even in the 11th or the 12th grade. It depends on yourself. You know, we are preparing all of you guys for national exam, whether you are in 10th grade or 11th grade, 12th grade, we are preparing for national exams. And these national exams that you are going to write in chemistry, biology, physics, math, English, and so on, these are going to be tough exams. They are not going to be exams that you can just quickly pass over. These are going to be tough exams. So we are preparing you so that when you go in the exam, you can do independent work. And that's why we are here. So we hope that you cooperate with us as we all try to learn math in a conducive environment. Thank you very much for your attention, and I hope to see you tomorrow in class. Okay, hey guys, welcome to class. This is the grade 10th class first period lesson under algebra, and the topic we'll be dealing with for this time around will be sets and its operation. Let's get quickly into it. Class, what is the definition of a set? You talk about set in the junior high section and you discuss the various types of sets and so on. So in 10th grade, we are going to give you an introduction to set, and we are going to go a little bit further from what you did in the junior high. So a set is a collection of objects of the same kind. So in order to have a set, you must have objects of the same kind. For instance, if you are collecting angiophones, put all of the angiophones together, you are having a set of angiophones. If you are collecting Nokia phones, put all the Nokia phones together, you are having a set of Nokia phones. Putting pens together, you are having a set of pens. Taking one marker and another marker and put them together, you are having a set of marker. So in order to form a set, these objects must be of the same kind. Great. We use capital letter to denote a set. So a set is denoted by capital letter. Then we use curly braces to enclose the elements of a set. So for instance, we use this capital letter to represent a set, and we use these curly braces to enclose a set. So every set must be represented by a capital letter, A, B, C, or D, and so on. Now, when we are talking about sets, we cannot forget to mention the types of sets. The various types of sets are connected one way or the other. So the first type of set we look at will be a finite set. A finite set is a set whose element can be counted. So for instance, if we enter the 10th grade class and we can count all of the students in the 10th grade class, we say that the grade 10 class, which is a set of students, is a finite set because we are capable of counting all of the elements in that set. The second type of set we'll be looking at is an infinite set. An infinite set is a set whose element cannot be counted. For instance, the set of counting numbers 1, 2, 3, 4, 5, and so on. You don't know the last counting number. So the counting number will say it goes to infinity, meaning it continues forever. And that set is called an infinite set. The third type of set we'll be looking at will be something called the empty set. An empty set is a set that has no member. So for instance, this set A, which is equals to this stuff is an empty set because there is no element within this particular set, and that's why we call it empty set. So we either use this symbol for empty set or we use this symbol for empty set. Either one of them will work perfectly well. From empty set, we look at equivalent set. Equivalent sets are sets that have the same number of elements. So we have set A to be equal to 1, 2, 3. Then we have another set, which is set B, to be equal to A, B, and C. We say set A and set B are equivalent. They don't necessarily have to have the same element within them. As long as they have the same number of elements, they are equivalent sets. The next step of set we will be looking at will be equal sets. Two sets are said to be equal if they have the same number of elements and the same element within them. So for instance, if we have set C to be equal to 1, 2, if we have set D to be equal to 2, 1. Set C and set D have the same number of elements within them and they have the same element. So in set C we have 1 and 2, in set D we have 2 and 1. It doesn't matter the order of arrangement. You bring 2 first and carry 1 second. It's the same set. So we say set C is equal to set D. That's how we write it. Now, from there we look at a set called a unit set. Unit set. What is a unit set? A unit set is a set that has only one element. So the members of a set are called the elements of that set. So any set that has only one element is called a unit set. An example would be set D is equal to 1 or set E is equal to 0. So this set has only one element and this set has only one element. So we call this unit set. Now, these are the various types of sets, and this is a general overview of what a set is. From there, we are going to look at operations on set. Operations on set. When we are discussing operations on set, we need to discuss 3 operations on set. We discuss union of set, we discuss intersection of set, and then we discuss complement of a set. But before discussing union, intersection, and complement of set, we have to discuss something called the universal set. Universal set. Now, what is a universal set? A universal set is a set that has all of the elements under consideration. So for instance, if we go to the classroom where we have different kinds of sets within the classroom. We have the set of chairs, we have the set of students, we have the windows, combining all of the windows, we have the set of windows and so on. So the classroom, which have all of the students, the chairs and the window, is the universal set. So if we are looking at something called subset of the universal set, we consider the students to be a subset, meaning they are under the universal set, they are within the classroom. We look at the chairs. The various chairs are subset of the universal set because they are within the classroom and so on. So a subset is a set that is formed within another set, and that's what we call a subset. So the universal set contains all of the elements under consideration. So if we are discussing the set of citizens of Liberia, right? The subset of the citizens of Liberia will be the various tribes. The various tribes such as Manon, Gio, Kwele, Loma, Bandi, and so on. These are subsets of the citizens of Liberia, even though together all of them make up the citizens of Liberia, but they are subdivisions of the citizens of Liberia. So you will understand it in that manner. So from the universal now we look at something called union of sets. We are discussing the union of sets. We are talking about combining the elements of 2 or more sets into one set, and that's what we call the union. So for instance, if we have set A to be equal to A, B, C, and D, and we have set B to be equal to A, C, E, and F. A, B, C, D, A, C, E, F. These are elements of both set A and set B. If we are finding the union of these two sets, it means we should combine all of the elements of A and B in one set without repeating any one of the elements, and that's how we call the union of these two sets. So how do we write union? We write A union B as A U B. So this is a symbol for union. A union B is equals to, we write all of the elements in both A and B in this one set. So we have A, so we don't write A twice, we only write A one time because A is in both of them. We have B here, we don't have B here, so now we write B within the union. Notice I will put all the elements together. C, so we have C one time, D, we have D, E, and then we have F. So A union B will be A, B, C, D, E, F. All of the elements joined together. That's how we call the union. Now the next operation we say we look at something called the intersection of sets. Intersection of sets. Under the intersection of sets, we'll give you the definition of intersection of sets. When we are discussing intersection of sets, we are discussing elements that are common to both sets. So when we get set A and we get set B, and we're talking about intersection of these two sets, we are discussing elements that are common to both set A and set B. So this is set A and this is set B. What would be A intercept B? So we use this N to represent intersection and use this U to represent union. So A intercept B will be elements that are shared by both A and B. So within A we have A here, we have A here. So it means A is a part of the intersection. We have B here, and we don't have B here. So B cannot be part of the intersection. We have C, we have C. So C is a part of the intersection. We have D, we don't have D. We have E, F, we don't have it there. So only A and C is part of the intersection of these two sets. And that's what we are talking about. Great. Now for the intersection of sets, we come to the complement. Complement of a set. When we are discussing a complement of a set, we are discussing elements that are found within the universal set and that is not found within a particular set under consideration. So, for instance, consider the universal set, which will denote as U. Universal set is denoted as U to be 1, 2, 3, 4, 5, and 6. This is universal set. And consider set A to be 1, 2, 3. So set A is 1, 2, 3, and the universal set is 1, 2 to 6. Set A is a subset of the universal set. Why? Because all of the elements in set A are found within the universal set. So 1 is here, 2 is here, 3 is here. So as long as all these elements are found in this set becomes a universal set, and this set becomes a subset of the universal set. So how do we find A complement? A complement can be written as A. And then we write the small prime over A. We call this A prime or A complement. And this will be equal to, so say the complement of a set are elements that are within the universal set and that is not in a particular set. So what are the elements in here that are not here? That's 4, 5, and 6. So 4, 5, and 6 are the elements that are in the universal set and that is not within set A. That's how we find the complement of a set. So we are going to give you work examples to do, and then we'll see how best you understand the concept of the type of set and the operation on set. Next, we'll be looking at something called the Venn diagram. The Venn diagram. The Venn diagram was named in favor of John Venn, who was a mathematician, and he came up with this idea of representing elements were set in a diagram. Within the Venn diagram, we use rectangles to represent the universal set. So we draw a rectangle, and we say this rectangle is the universal set. We use cycles to represent subsets of the universal set. We have already told you what a subset is. So taking this set to be set A, and this one to be set B, this set A, and this set B, and this entire rectangle is a universal set. We want to represent this information. This is, what is it? This is set A and this is set B. We want to represent the information within this set. So this portion of the cycle that is in both set A and set B is the intersection of these two sets. So if we want to write the intersection of these two sets, we come right here and find A intercept B. A intercept B is A and C. So we write A and C right here. This portion of this diagram is elements that are within only A and are therefore within B. And this portion is elements that are within the B and are therefore within A also. So one of the elements in A alone, elements in A alone will be B and D. So it will be B and D. And together, the elements in A will be A, B, C, and D, as you can see from the diagram there. The elements in B alone, like that in A, will be C is right here, so it will be E and F. So E and F will come right here. And then this portion of this rectangle that is outside of A and B is outside of both the union. So we take the union, we take all these elements. It is outside of the union of A and B. It is within a universal set, but it is not within A or B. It is outside of this circle. So as we go on, we are going to look at practice problems under finding intersection of sets, union of sets, and so on. And then we will start solving 2 sets Venn diagram problems and 3 set Venn diagram problems. Thank you very much for the class. And if there's any question that you have, we'll address those questions in the classroom tomorrow. Hope to see you guys in class tomorrow, and bye. I'll do an editing right here.